Hello guys, how are you? Last lecture we stopped at the sections and we learned how to make layers. So now we will apply what we learned on a real building. If you understand this concept now, you can apply it on any kind of buildings. So this is not structural drawing, but because it's the most common drawings and it's the easiest to understand, so we will go for it. But you can apply on dams, you can apply on bridges, you can apply on steel structures, you can apply these concepts and these basics on any kind of structure. So, what I mean is that this is what we did for top view, front view, and right side view. So we transferred the 3D view to three different 2D views. Why? Because we want to understand on 2D what is this 3D shape. So the same thing we should do for our building. So to understand more, I think I've showed you this before. Let's start by this one. So this is the basic structural sample project from Revit. So if you download and install Revit, it will be there. So what we can understand from here, here is the different views. So this is the structure that it's steel and concrete. So it's composite structure, and these are piles. So regardless of what is it, we want the concept. So this is the 3D model that, let's say, it's a villa. So um, how we can understand from the plans? So you should draw a plan for every elevation that it's changing. So for example, this is the foundation plan. It's a changing here now, the zero plan, the ground plan. So also this is the first floor, let's say level 1, level 2, level 3, rooftop. So every level that the structure is changing and the elements are changing in place or new elements exist, you should draw a plan to understand what is happening. So let's start from the foundation plan. So these are the piles that you may see here, right? So you go up to the next level and so on. So you can see the structure is changing and new elements exist now uh, on every level or elevation. So this is, if you didn't understand this one, we can go for this one. This is more some simple project that is all concrete, reinforced concrete structure. So again, the same thing. We should apply the what we learned on this building. So this is the 3D model. If we go for the top view, you can see this. If you go for the front view, you can see this. Same thing for the right side view. But here, as we learned here, that we may need sections for different levels. So here, section DD, you can see that it's different from section CC because the shape is different. But here it's now more complicated because you have like 16 floors, so 16 top view plan, but in section preview. Also for the front view. So the front view is like this, but you need every front view from here, maybe inside the structure, it will change. For example, here we have stairs. So you need a section like this to see what is happening for the stairs. How many stairs, how much is the height of the each one. So again here for the core and so on. So you need sections and the same thing for the side views or also sections. So how we gonna apply this one? So let's start by the plans. So you may see that here the foundation level and the ground level. Then from the first floor until the last one, it's the same. So you can see the foundation plan, let's call it plan, or the top view of the foundation. You can see. So now the first story, because we are looking, as I said, this is the first story we called it. So we cut and see to the to up. Okay. So uh, you will see these these outlines. So from the second story it will change because this is we see from top. So and so on. 3 same, 4 same until the roof. Okay. So when you are drawing the plans and for example you are working in a company and you want to submit the plans to the engineer or to the consultant. So you will of course give him the foundation plan, the first story, and then you may give one plan for this one and you can type here typical story from second floor to the roof. Okay, so you only need to draw the necessary drawings that it may be different from the others. The same thing for the sections. Okay, so here, as I told you, this is you can see this one is the section. So if we do like this, so it will be similar to the left side view, but as a section. You can see. So if we go to the 3D and the right side view, it's like this. This is the right side, but the section is different. Why? Because it's from the stairs. We cut through the stairs and we want to see what's happening. So now you understand the idea. Now what you should do to start understanding what is that and what is this. So if you go to this shape, and assume that this is now the area that we have to build in. So you understand me? You have to build in this area. So let's assume that this is in meters, so it's a big area, or if it's in centimeters, it's 4 meters, too small. 42 meters by 1 by 15, logical. So anyway, I just want to deliver the idea what we want to do. So let's forget the dimensions. Let's assume that this is the land that we want to build in it, a building. So you say, okay, what is the first thing you should do? Or you shouldn't, but to understand now from zero. Now, normally the architectural engineer design and model the idea or the concept of the building. So the structural engineer will have the model ready. He won't draw axes and columns and the model. He won't draw it, but he will edit and he will design. So, for example, the architecture will put a column here. Sorry. Let's say we put a column here. This is the column, right? Because as you can see, if this is a column in the plan, it's like a rectangle. And you learn this. Why? Because from top we are seeing the rectangle shape. So here also we are seeing from the top view. So this is the column. So the architectural assume that this is the dimensions of the column. It doesn't mind for him how much, but he said, I want a column here. So he will deliver it to the structural engineer. The structural engineer will say, okay, the place is good. I will design the dimensions. I will calculate the loads, etc. Then he will say, for example, if the dimensions match, he said, okay. If doesn't, he will negotiate with the architectural engineer. What else? Yeah. Also, he could say that the place is not good. I want it here, for example. So a negotiation will be a part between the architecture and structural engineers. So this is the column. Now let's assume that here, here, like this. Okay. So we have these columns. Copy like this. So you have these columns. So in the plan, when the workers will install these columns in site, they want to know how much is the dimensions between the columns and where the columns are um, apart between each other. So now the idea of the axis is that so you should illustrate that we have this column. So the axis may be at one of the ends of the columns or from the center of the column. It depends on how much columns you have. So here For example, we have one, two, these columns. So an axis between its all centers can be drawn. Now here, if this axis can be from the center or from the left end for these two. Now these two won't fit on the same axis for this one, right? Now here in this project, I haven't drawn any axis because I just not converted, transfer from the robot software application to here, so there is no axis, but you will understand now. So you understand now we want to draw an axis between everything, between the columns and the walls also, because walls are uh, big columns or long columns. So this wall, you can see it may be at the same axis of this column. So if the axes are from the middle, from the center of this column, it may be for the same to this wall. Same thing on this column and this wall and this wall. Okay, so now if you want to draw the axis, you may draw like this. You can copy from the middle or from each end, doesn't matter now. We just want to illustrate. Now the last one, preferably we want it on the end, not from the middle. Okay, so now this dimensions fits like this. Okay, so now you may say that okay, now this is the vertical axis. Now the horizontal axis from here to here and from here to here. Dimensions. Specify second extension. Okay, so this is our axis for this sample. So you may name it now. You may draw a circle like this, move it and from here to here, then copy from here to here, to here, to here, to here, and as we did, copy A. Let's scale it down a little bit. move like this. So A copy from here to here. Now B, C, D. Same copy from this side. You see, now I wanted to copy this circle from this point. Okay, why? Because I wanted to copy from here to here, right? So now when I'm selecting and typing the command copy, I can't snap to this point. Why? Because here the object snap options, here you can check this one. So you may now snap to the quadrant of the circles. Now again, after I checked it on, copy, you can see I can snap on it. So copy from here to here to here. This is one, this is two. So this is the idea of axis. Why? Because we need to know the dimensions or the spaces between the columns or the other structural elements, between the walls, between any vertical structural element. Now you may change this line to dashed lines here. There is no dashed lines, you can load this one, for example. Okay, okay. Now you can again select dashed. I prefer the dashed uh, type, line type, to understand that this is not an element or a structural element. This is only access for the plants. So now you understand why we did this. Now we will go back to the idea. So the idea is that we have the axis now between the columns, walls, everything. Now how we will illustrate the building. Now we have three things, right? We have the plans that is top view. We have the sections that may be front view or right side view. And we have the 3D view. So the 3D view is like this. This is the 3D view. We want to illustrate this 3D view into 2D plans. So we have to draw first the top view plans of every necessary floor, and we should draw a front view and side view with their sections that are necessary. As I said, for example, the stairs. Now, with this, we may illustrate how is this building in 3D. So, now what elements are in this plan, in this structure? Columns, you can see columns, and beams, these red lines, and the slabs. So, between the slabs, between the beams, the slabs are shaped, and between the columns, between these two columns, there are beams. And of course, structural walls to resist the seismic forces, and the stairs. This is as simple as it is. Now, the the curve, this the model shape will different from each one to another. You can imagine, you can take a look of on the buildings beside your apartment, take an idea how is columns, beams, and slabs are shaped with each others. So, uh, so this is an axis. So, and this is the columns. Now we may say that we have beams between each two columns. So now this is I draw it um, with default dimensions, like I don't know how much this is. This is 24. So let's assume that this is 25 by 8. It's not logic, of course. Now this this is just for understanding. Normally the least at least the column should be 30 by 30, 30 centimeters by 30 centimeters. So this is wrong. But to understand, now we may illustrate the beam. Now how is the beam illustrated? Now if you go to the 3D view, you can understand. So this column and this beam between them. So now the width of the beam match the width of the column. So this is 50 by 60. So this is 50, this is 60. And the columns must be 50 by 90. So this is 50, this is 90. So you can understand that this column and this column and this beam between them. So the plan would be just two lines connecting the two columns, right? Something like this. Now, these four columns has these beams between them, you can see, and these four beams has this slab. Sorry, you see this slab between this. So this is the simplest way to understand. You have four columns and four beams and one slab between them, and so on. So this is the cantilever. There's only three columns and two beams. These two beams and this slab, because it's cantilever. And here, sorry, here. So we will illustrate on the top plan or top view plan the beam like this. Now this is like this. Let's go back to this one. So this is column, beam. This illustrate the beam. What else? If we draw now beams like this, Okay, so we have beam, four beams, four columns. Now, directly the slab will be shaped between them. So no need to draw this slab. Just what we will do, we will say the tags on each member. So this is, we will call it, for example, C C2. So columns has numbers. So C1, C2, C3, and so on. C2 and its dimensions, for example, 30 by 30 in centimeters. Okay, this is also B, also has numbers. So how you will number it? You will number, for example, this is the first floor, so this is B102. So this one is 101, 102, and so on. This is S only by its thickness. For example, 15 centimeters. Here also you may say that this is, for example, 50 by 30 by 50. So in centimeters, this is 30 by 30. So this is wrong. So it will be a square. This is 30 by 50. Now the 50 is its height. So it's not the length. Most of the students make mistake. So again, the dimensions here for the column is these dimensions, width and height. Okay, so these columns you can see 100 by 50. So this is 50, this is 100. The length is according to the floor height. So for example, the floor height here 3, but it doesn't matter on the plan. The beam, its name is 50 by 60. So 50 is its width from here to here. 60 is its height from here to here. Now the length is again depending on the spacing between the columns. So it doesn't matter. So the height will not appear on the top view because you are seeing from top. You can see the height doesn't appear on the top view. So this is 30 by 50 depth. The depth is 50. The same thing for the slab. This 15 is the thickness. So it doesn't appear here on the plan. So for this one, it's 30, rigged slab 30. So the thickness is 30. So this is from here to here is 30. But on the plan, it doesn't appear. So this is an introduction to the plans. We will work on a real villa to understand more, but now this is only an introduction. Uh, so I will recap what we learned today in AutoCAD on these things. So first thing we learned how to make the line type dashed. So if you want to start over from the beginning to draw an axis, so now I will press F8 like this. So this is the first line of the axis. Yeah, so this is the first line of the axis. Now we may offset. Did we learn this offset? This offset from here or O for offset. Here it says specify offset distance or through. So let's say we want the distance is 500 centimeters. So 5 meters, it means 500. This to here, again 500, 500. Now we will draw the first line of the first line of the uh, horizontal axis from here to here. Again, this offset distance is, let's say, 4 meters, 4 meters. So let's learn something new. Let's copy because I want this to stretch more to down. So I will copy this a little bit to here. Now I will extend this extend. Now the things I think I said it for trim and extend, you can type extend and again select all. Why select all? Because what how this command work? This command asks you want to extend this line to here, right? So it will ask you first to which line you want to extend. You will select this one. Then which line you want to extend this one. You understand me? So instead of selecting the line you want to extend to, you will select all the lines on the drawing. So now whatever you want to extend, it will automatically extend. So to understand that, I will try extend. Now select objects first if we want to try it how the traditional way. You will select this one, then you will select this one. You see? So first we selected the objects that we want to extend to, then we select this. But if we Control Z now, EX, enter. Now here it says select all. So again, enter. So all the lines now are selected. You may extend to. So now this will work for each lines. Now I will delete this one. So it will be similar. Now this is our axis. Now you have two options. Either select like this and select the dashed ones, or you can Control Z. You can create a new layer as we learned before, this one, and name it axis. And you can change the line type here for this specific layer to ISO dash. Okay, now you may select these lines and put it on the axis. You understand me? Now you may go back to the zero layer and its default. So let's create a layer called bubbles and let's make it yellow. So circle like this, move from here to here, then copy, sorry, then you may copy from here to here, then copy from here to here, again copy like this. So this is our axis. Now you learned how to draw axis. This is this is for example if you want to start from zero, you are designing. For example, you have an area with Let's see how much is this. Yeah, we said 44 meters by 4, so 8 meters by 15 meters. How much? You will multiply and you have the area. So you said, okay, I can make this is regulations in codes in the standards. So it says, for example, at least the columns should be spaced 3 meters between each other. So this is regulations. You may learn it in other courses, but for now you designed your own axis. So now if you so this is on bubbles. No, this is still not on bubbles because the color didn't change like this. Again, you may copy this text, put it here, scale it up again, F8 in the middle, copy. Now this is P. D. Now copy from here to here. You see, copy is easier from here to here. One, two, three. So this is your axis now. You may now draw your columns. So rectangle, the corner is here. Now say specify other corner or dimensions. You want to insert dimensions 30 by 30 like this. So this is your column. Let's create a new layer for columns. Let's make it red. You should transfer it to this one. Now you may copy from here, here. Now this should be like this. So move from here to here. So the end should be on the axis, but here it doesn't matter. You may transfer it to the middle, to the center. Now copy. Also, these you may move it to the center like this. Okay, then copy. Now these copy from here to here, to the ends, to the both ends. تمام. This is your columns. Now you may create a new layer for beams. Make it green. Double click for drawing on this layer. Now lines, you may draw lines here like this. So now you understand that this is the plan, the top view the section of the top view of the plan. So this is like this one. Okay, so you are sectioning for the top plan, the top view, to get this kind of things. Okay, so this is what we are doing. We are This is our building 3D view. We are sketching the first floor, let's say. So we have this elevation. We can assume that this is first story plan elevation. So you should say that this is on which elevation this plan is. So this is on 0.0. So this is the ground floor. Okay. So now you know that this is the ground floor. So it started from here. This is the ground floor. Now we are putting the columns in their places, putting beams and slabs for the first floor. Now the foundation is minus, for example, minus 2.5 because it's underground. So you always, everything underground, the elevation is minus, everything up is plus. So here, plus 3, plus 6, plus 9, and so on. You can, okay, you can see it from this project. You can see this is the foundation minus, this is in millimeters, so this is 2 meters point 7 minus 1 meter point. This is minus 0.5 meter, 55 meters. This is 0, so the ground will start from here. Okay, all of this is underground, and so on. You will go. This top of the parapet is 6 meters. This is 9 meters. So here 9 meters, 6 meters, and so on. So, and this is, let's see the axis. You can see this is what we are doing. This axis A B C 1 2 3 4 5 6 7 8. So because this project is like this, so you need access on every um, element. So here you want access, here you want access to illustrate where is where. So here and here and here. These dimensions between this one and this one, 3 meters dimensions. You can see dimensions between this one and this one is 3 meters also. So you should illustrate the dimensions between each element to for the workers to know how to install it. So let's go back to this one. Now we are just sketching a normal floor, columns, beams, and slabs. So you can copy now because remember, let's like this. Continue from this one. Yeah, there we go. So remember that we make it symmetric. So the spacing are equal. So you can copy now from here to here to here. Now you see this line, so you can extend. Remember, EX enter, again enter for selecting all. Now it's like this. Now you may do like this, then shift for deselecting. Shift, hold shift and click for unselect. Copy. Now the vertical beams, you know, copy, copy. Okay. So now the tags. So you should say that, okay, this is this. So we can start this C1, C1 30 by 30, C2 30 by 30, C3, C4, C5 until the last one. Same thing for beams. Remember, B101 30 by 50. So this is 30. The 30 is the width. From here to here is 30. But 50 you cannot see it, so I assumed it 50, the depth. Now B102, B103, B104. Same thing for the slab. For example, S15. This may scale this. You can like this. So this is a typical floor. Now you can understand how. Now the next floor, for example, the same. So you just copy the same, only here, second story, plan elevation 3 plus here plus 3 here, first story 0, second story 3, etc. For example, 2 floors, villa. Now the foundation, we will learn it uh, in a future lecture, the foundation level. Uh, okay, now the layers are important. So let's make a new layer that this is tags. Okay, and tags in red. Now let's learn something new. We want to select the text here, right? Only the text. So you will select like this. We want the text. Click, right click, quick selection. Now here apply to the current selection, this one. Which object type you want? The text, right? Um, you want to select the text, the layer, on which layer this layer is on top view. Okay, so the text is on top view layer. So again, we will do like this, right click, quick selection. I want the text on layer top view. You see, okay, now only the text are selected. So this quick selection is very useful for you if you have a complicated plan and you want to select some specific elements on the plan, you may use this one. Now this I want to transfer it to the tags. So you can see like this. Or you may make each one for beams on the beams, for columns on the columns. It's up to you. This keep it on the tags. Okay. I will upload this today, and if you have questions, we may go online. I I prefer to do like this: record a video, then whenever you want, watch it. Then, if you want questions, you may ask me, and again I record, or we may go live. Now the thing is, you have a project like midterm. This is the project. Remember the same things we did: top view, front view, side view on AutoCAD. Simple like this. Now these, draw it as it is. So it's 30, draw it 30, 15, draw it 15. Okay, 5, draw it 5. This is the diameters is 50, 50 and 20. This is 115. Everything is oh yeah, everything is clear, I think. If you have further questions, ask me. Today is 20. The submission is after 2 weeks. So today is Monday, not next Monday. The next one you will submit it on the OZAME, okay, as a midterm project. Easy one, I think. Don't worry. Now this line is parallel to this one. So this is from the outside, not inside, okay? So it's not a hole. It's you can see it's like a camera. So this is the lens of the camera. So it's outside of the camera. So this is 20 outside. So this is 30, then 20. Okay. I will upload this today also. Further questions, ask me, or we can go live tomorrow maybe. Good luck. Thank you. Next lecture we will learn about foundation, and future lectures we will learn about sections. Try to understand, try to imagine why this is like this. I said it's because we structural engineers, not you, maybe you will be water engineers or bridge engineers, but in the structural engineering we cut and see to the top. So if you are now sitting in your room, you can imagine that if you are looking up now this slab is on the top. This beam, if you have beams in your room, you can see. If you don't, maybe it's with the wall, and the columns also. So this is a cut the view to the top, a cut the view to the top. If you want to understand it here, mm, so if you are sitting here, okay, we are cutting and seeing the top. Okay, so you are sitting on this floor now, your room, but we are sketching We are cutting this column, we are seeing this beam, we are seeing this slab. Okay, so um, okay, I think it's clear. So you remember this sectioning, because if we are cutting, the pattern will change. So this pattern should be hatched by which one? This one, right? Not this one. This one. Yes. Why? Because we are cutting through the column, but the beam we are not cutting through. The slab we are not cutting through. Only the column. Only the column we are cutting through and looking to the top. So the beam same, the slab same, but only the column we are cutting through. So we are seeing it like this. So each column should have this pattern, right? You can see, I told it you before, if you hatch one element, then exit, then copy, each hatch will select it on يعني separately. You will select the hatch separately. But if you click hatch, then you will hatch this one, for example. Now you can see also this problem. You will face it if you draw the columns. Then you want to hatch. So the hatch will be like this. So what we will do? You will isolate, hide, or locks all layers except those of the selected objects. So you will know now the benefit of layers. So remember we make a column layer. So you select this one, columns, then you press isolate. So everything except the column layers will disappear. Now you can easily hatch like this. You can see, yes. Now unisolate. Everything is going back. So you see these are a group because I did it all once in one command. So this is like a group. This is the center of the group. But this is separately, so it's one. Okay, now it's like this. Same thing here. Thank you. Goodbye.